I am convinced we all have experience with restless sleeping. We all know the feeling of having too warm and feeling uncomfortable in bed. And what happens when you feel too hot or too cold? You turn around, you change position and try to cool down or get warmer. Either you wake up or you have a very nervous sleep. I'm Chris and I will explain you what sleep comfort is all about. As you can see in this graph, comfortable sleeping has to do with our comfort zone. When the temperature in our bed becomes too hot or too cold, we get out of this comfort zone and start feeling very uncomfortable. Our body temperature is always approximately 37 degrees Celsius, and this is the same all over the world. And we all know 2 degrees less and we are undercooled, and 2 degrees more and we have a fever. But our skin temperature, however, is 32 degrees Celsius. So if we want to sleep comfortable, the temperature around our body may not become too hot or too cold. Now, the comfort zone is the temperature between the skin and the textile and is defined between 28 to 30 degrees Celsius. Once we get out of this zone, our body starts sweating or gets cold and we start turning around. So, wouldn't it be great if we can always sleep in this comfort zone? An understanding of the bedding textile design can best be developed by considering the ability of the human body to maintain a suitable rate of heat loss. The microclimate in the bedding is determined by the ambient temperature and bedding design, apart from the subject's clothing cover. Heat loss in bedding occurs through leakage of microclimate air to ambient temperature through bedding upper layers and with the conduction of heat to the mattress. Now, duvets and even sheets in summertime also have tendencies to overheat, since they allow very little heat exchange between ambient temperature and microclimate. And this is why very often we will have too warm or too cold in bed. So we came up with a solution, PCM, phase change materials. They possess the ability to change their physical state from solid to liquid within a certain temperature range. These materials absorb heat when the temperature goes up, storing this energy temporarily, and release the energy as heat when the temperature cools down again. Now, as mentioned before, the temperature around our body whilst sleeping should be between 28 and 30 degrees. This is what we call our comfort zone. Now, the PCM buffers the upper from 30 to 33 degrees and lower from 26 to 28 degrees limits of this interval. Thanks to these PCM, we can stay longer in this comfort zone and sleep much better. Phase-changed materials are microencapsulated and applied to fibers in our mattress fabric. Usually people always use some kind of thermal insulator, even in summertime, although much thinner. So if the temperature in our microclimate starts to raise, the PCM starts to change from solid to liquid state. And our body does not get overheated, as the PCM will absorb that energy. How can we explain this in simple terms? Compare it with melting ice cubes. Melting ice from, for example, -10 to 0 degrees goes quite fast. However, once we get ice of 0 degrees, the ice absorbs the energy to become water. And this process takes much longer. It is the ice that absorbs the energy, and this is used to change the phase from ice to water. Now we do exactly the same whilst using PCMs in bedding. Once we go above the comfort zone, so when the temperature in our microclimate gets over 32 degrees Celsius, the PCM absorbs the warmth and uses it as energy to go from solid to liquid state, avoiding that we feel too hot, too warm and uncomfortable. Millions of very small capsules containing phase-change material are applied on the surface of the fiber of the mattress fabric. Important in this process is that the microcapsules are not applied through a binder or a coating, which is acting as a sort of plastic cover over the mattress fabric. Our patented technology is based on the reaction of the microcapsules on fibers without the use of binders. This means that the mattress fabric is breathable, which increases comfort. Now, due to the reaction of the microcapsule and the fiber, they become one, which makes the mattress fabric washable and the effect long-lasting. It is crucial to note that our comfort solution has been thoroughly tested. In this movie, an untreated and treated sample of mattress fabric are being put on a warm plate of 40 degrees Celsius. The warm plate simulates our body as a heat source. A heat-sensitive camera is observing the temperature of the samples. The blue color indicates a cold temperature and the red color a warm temperature. Now, on the left you see a fabric with phase-changing material. On the right, an untreated fabric. What we clearly see on the treated sample is that the warmth of the hot plate is being absorbed and used to change the PCM from a solid phase to a liquid phase, meaning that the phase changes at a constant temperature. Therefore, you see that the treated sample will warm up much more slowly than the untreated sample. The change of the temperature can be seen in the following curve. It is obvious that our solution brings real added value to our sleep comfort. Mattress fabrics containing phase change materials react immediately with changes of temperature in our microclimate. The use of PCM embedding will make sure that you do not longer feel too warm or too cold in bed, which means that you will change position less, conferring a better sleep. So it is indeed a great way of sleeping very comfortable. It enhances thermal comfort, we will no longer feel too hot or too cold, but most of all, it enhances our quality of sleep. And let's be honest, that's what it's all about. Better living thanks to better sleeping. Good night.